Hi, this is Paul from Foresight Tech. In this video, I will introduce how to find the future value for doubling time growth model. Here is the future value formula. To find the future value, we only need to directly use the doubling time growth model, which we learned from the last video, right? Let me draw a graph to show you the meaning. And I draw the x coordinate, which is the time t, the y coordinate, which is the value pt, and suppose we know the initial value. Let me put here p0, and we also know the doubling time growth model, which is like this way. Okay, means we know the doubling time, right? Okay, so TD we know, P0 we know. Now we have these questions. Give any specific time T. Do you know what is the Y value, or what is the value of your model, which is what is PT? Okay, that's the question. See, we need to find out what is PT. PT we call the future value. Okay, how? We just use the formula. Can you see? Here is the formula. Because we know the initial P0, we know TD. Of course, we also know T, right? Okay, so we can directly use the formula. Or you can say we just evaluate the function or the model at a specific time t. Okay, now let's practice how to use this formula. Here is the first question. The doubling time of a population of flies is 8 days. If there are initially 100 flies, how many flies will there be in 16 days? First, we know the population of a fly grow exponentially because there's a doubling time, right? And we look at the question, how many flies there will be in 16 days, which is the future value. Now we need the future value formula, right? Let me copy the formula first. So I put the formula here, which is PT, the future value, equals P0 initial 2 raised to the power of T over TD, right? That's all we need. So now we need to find the parameter. See, first 100 fly is initial P0, right? Therefore, in the formula we know the initial. What is T? We do know is 16, right? That's T. What is TD? Doubling time. We do know is 8 days. That's TD. See, now we can evaluate the model at T equals 16, right? So we plug everything in. So the future value at 16 is, all you say is P16, okay, equals initial is 100 flies times 2 raised to the power of fraction T is 16 and TD is 8. Okay, now do calculation. What do we get? We will get 400. Okay, so that's the answer, which means that the future value is 400 at the time 16 days later. Okay, for this specific question, we do have another method. Let me call this method 2. Okay, I will use the definition. Can we see? At the beginning is initial P0 is 100. Okay, you know the doubling time. Okay, which means 100 will go double, goes to 200. And how long we need the doubling time, right? Let me put here how long we need TD, which is 8 days. Make sense? And then again, from 200, we go to double. Go to 400. How long we need? The same, we need another doubling time, which means TD equals another 8 days. Imagine if we put these two doubling time together, how long is the total time? See, 16 days. That's 16 days exactly is the question. Okay, which means 16 days cover 2 doubling time. Therefore, we can directly find that the answer is 400. Make sense? Okay, so the same answer. Look at the method 2 is much easier, but the method 2 does not always works. And there works for good numbers like 100 goes to 400 or 16 days cover 2 doubling time. If we change 16 to like 20 days, which means it's not a 2 doubling time, it's 2 point something doubling time. Therefore, this method does not work. We have to go to the formula. Let me practice one more question. Here is the second question. Suppose that a certain city's population doubles every 12 years. If there are currently 10,000 people, how many people would there be in 34 years? And the population grew exponentially because it says double every 12 years, right? We do have a doubling time. And the question asks how many people there be in 34 years, which is the future value. Okay, so the first method we can use the formula directly, right? Do you think this question we can use the second method? And in the first question we used, no, it does not work because 34 years is not an integer number of the doubling time, right? 34 years is like a 2 point something doubling time. So we cannot directly use the definition of doubling time. Therefore, we have to use the future value formula. Let me copy the formula first, which is a PT, right? The future value equals initial value 2 raised to the power of T over TD. That's the formula we need. Now, we need to find the parameter. What is P0? It says currently, okay, is the initial value, which is P0, we know. What is T? It asks 34 years later, which means we know T. What is TD? Doubling time. See, 12 years double, that's TD. So we also know. Now, easy. We plug in every parameter. So PT, the future value, equals P0 is 10,000 times 2 raised to the power of T is 34 years. TD is 12 years. See, we have everything. Plugging this into the formula to calculation, we will get this number, okay, around 71,272. That's the answer. That's all. Thank you.